Bismillahirrahmanirrahim. Okay, today I'm going to show you how you can solve first order differential equation by using Bernoulli method. Okay, so I will show you one by one. Okay, the first question is whenever the coefficient of dy dx equals to number 3, which is not 1, and the second one is where the coefficient of your dy dx equals to 1 already. Okay, we do this one first. Okay, this is where the coefficient of your dy dx equals to 3. So you have to make this equation be in standard form. So you change it to standard form, where the standard form, it will be the dy over dx. The coefficient here is 1, plus whatever you have, the coefficient of y will be the fx, and the right hand side will be the gx. So this is the standard form. So in order to have the coefficient of dy dx equals to 1, you have to eliminate this 3. So you divide all this by 3. So you multiply all this equation with 1 over 3. And then you expand. So what you get will be, this is your step 1, yeah? Will be just dy over dx, plus you have 1 over 3y equals to x y power 4 divided by 3. Okay, so now the coefficient of dy dx equals to 1 already. Okay, next step, you identify your n. Since this is Bernoulli, so you identify your n. This is the n. Your n equals to 4. So you have to, after you have identified your n, then you need to find the expression for 1 minus n divided by y power n. Okay, so your n is 4, so you have 1 minus 4 over y power 4, so you will get a negative 3 over y power 4. You can bring y power 4 up, or you can just let it be this. Okay, 3. If you want to bring it up, it will be negative 3 y power of negative 4. Okay, so you have to multiply this expression. Step 3, multiply this negative 3y power of negative 4. You multiply with the whole expression that you have made the coefficient of dy dx equals to 1 just now in step 1. So you put the dy over dx plus 1 over 3y equals to xy power 4 over 3. And then you expand. So you get negative 3y power of negative 4 dy over dx. The 3 and 3 can be cancelled. And then you have minus y power of negative 4 times y, which is, so y power 1, you get y power negative 3. Okay, equals to y power 4 and y power negative 4 will cancel off. 3 and 3 also cancel off. So what you get on your right hand side is simply negative x. Yeah. So this is the expression that you get whenever you expand the operation. And then your next step is we have to introduce any letter. Say I introduce z. Z equals to y power of 1 minus n. So y power 1 minus, our n again here is 4. So we have y power negative 3. So then we find the expression for dz over dx. So we have to use implicit differentiation here. We bring the negative 3 down here. So negative 3y power of negative 4 minus 1. And at the back here, you just add dz over dx. So if you refer to this expression, sorry, it should be dy, since you have y, not dz, dy. Sorry, dy over dx. So what you have here is similar to what you have here. So we are going to substitute this expression with dz over dx. We substitute it here. And y, z just now equals to y power negative 3. So we are going to substitute this to y power 3 here. So now this expression becomes, okay, here we substitute with dz over dx. So we have dz over dx minus y power negative 3 is actually equals to z. So minus z equals to negative x. So up to here we can solve. So our new dependent variable is z, and then our our independent variable is x. So this can solve using the integrating factor. Okay, so if you identify your integrating factor, the coefficient of z here is negative 1. So we know that our fx equals to negative 1, and on the right hand side here equals to g. The gx equals to negative x. Okay, so for solving this by using the integrating factor, we have to find the integrating factor. So the integrating factor, the symbol of ix equals to the e power of our fx, which is negative 1. So when we integrate negative 1, we get negative x. So this is going to be our I. Then you substitute into the formula where you have z multiplied with the ix equals to the integral of the ix multiplied with the g. Okay, so z is z, but ix equals to e power of negative x equals to integral of I again e power negative x, and our gx just now is our g. Yeah, negative x dx. So when we have a product of two functions here, e and x, so we use LOPAT. We use integration by part. We use integration by parts to solve this. So you have to let your u be the polynomial, negative x. You differentiate u with respect to x, you get a negative 1. So du equals to just, this is negative 1, negative dx. So our dv equals to the e power negative x dx. So v we get by integrating this. So we get e power negative x divided by negative 1. So therefore our z e power negative x becomes, the formula is uv minus integral v du. So u is negative x, our v is negative e power negative x, minus integral of v, we have a negative e power negative x du equals to negative dx. Okay, so we have a negative and negative become positive, so we have x e power negative x minus we have a minus, we have triple negative sign, so we have a negative, but when we integrate this, we get e power negative x over negative 1, so we get a plus here, and then we add a constant c, yeah. And then we want to solve for y. So we still have z here, but z equals to, where is our z? Okay, z equals to y power of negative 3. So we substitute z equals to y power of negative 3, yeah. So we substitute into z, y power negative 3 at this z, e power of negative x equals to our solution just now, e power negative x plus e power negative x plus a c. So now we have, okay, this is not an IVP problem, so there is no need to find the value of c, So you want to solve for y, or since the power of y is negative, I want to bring it down here. So e power negative x over y power 3 equals to x e negative x plus e power negative x plus c. So I just bring y power 3 to this side. So we have e power negative x over the whole expression here equals to y power 3, okay? Or you can simply find your y by taking the cube root of this expression. You can bring it down, or you can simplify further, or you can just leave your answer like this.